Hello everyone. Write down mechanical properties of fluids. Now when we say fluids, that means liquids and gases both. The concepts are same. Mostly we'll be dealing with liquids, but at times you will see some examples on gases also. First thing which we notice when we study fluids is that we are no longer interested in force. Instead, we are interested in pressure. And pressure is something which everybody knows is force per unit area. That's how we define pressure, which is force per unit area.
Excuse me, sir.
Yes.
Sir, you're not audible.
Let's start everything again. Mechanical properties of fluids. When we talk about fluids, it means liquids as well as gases. But mostly we'll deal with liquids. A few examples you will get on gases, but almost entire chapter it is liquids which we are interested in. And when we talk about gases and liquids, we're not interested in force. Instead of dealing with force, we study force per unit area, which you already know is what? Pressure. Now, let's define this pressure part first. Suppose we have a surface and this surface has an area of A. This is a side view. The entire surface area is what? A, and you're looking at the side view of the surface. On this surface, a total of F force is acting. Then P is F upon A. That's how you define pressure. But when we define force per unit area, we need to remember one important thing. And that thing is, this force should be always perpendicular to the surface. For example, if we have a situation like this, where force, let's say, makes an angle theta. This is the surface area A, and all these arrows, I am showing all these arrows a single force F, which is acting at an angle of theta. So if this is the force, you can always resolve this force into its components, which are F cos theta and F sin theta. We have a surface. On this surface, there are two forces acting. One is the, you can say, horizontal component of F cos, and the other one is tangential, which is F sin theta. Let's see how many of you can visualize this part. What do you think? Which force component is going to produce pressure? Is it the cos component or the sine component? Mention this in the comment box. Which component is ultimately going to produce pressure on this surface? And I hope everybody is writing F cos, because F sine is simply what? Tangential force. If this is a tangential force, then it's not going to produce any pressure on this particular surface. Pressure is coming because of cos component, and therefore this particular figure, pressure is not F upon A. Instead, pressure is F cos theta divided by A. Now, this type of force which always acts perpendicular to a surface, it has a special name, and we all know that is called what? Normal reaction. So if I replace pressure as what? N upon A, then I will always get a correct result. In this figure, entire F is your normal reaction force. In this figure, F cos theta is the normal reaction force component. This F sin theta is not producing any normal reaction. Normal reaction is coming because of F cos theta component. So, it's better to remember pressure as normal reaction per unit area. Normal reaction, you all know, is what? A force which acts perpendicular to the contact surface and towards the body. I cannot write T upon A. I must write what? F. What is F? Normal reaction force. Write down this and then we'll write a few statements. Draw this figure first, then this. Don't forget to cross this thing, and then write down F cos theta divided by A. By the way, all those who have seen yesterday's lecture, write down yes in the comment box. Now write down the statement. When we write P equals to F upon A, F should be always perpendicular to the surface. When we write P equals to F upon A, F should be always perpendicular to the surface. inside the bracket, any tangential component of force will not participate in pressure. Now, once we have defined pressure this way, we can establish certain formulas for this. Look here. Suppose we have a beaker and this beaker has this much water. Height of water column is h, mass of the water is m, density of the water is rho, or any liquid for that matter, and cross-sectional area of the beaker is A, base. We are interested in pressure at the bottom of the beaker or at the bottom part of the liquid column. This thing will be called a liquid column. This figure, with the help of FBD technique, free body diagram technique, can be arranged in this manner. We have a surface, and for the time being assume that we have a mass m. This is mass m. If this is mass m, then downward force of mg is acting on it. A normal reaction is coming from the support, which is the bottom of the beaker. This is n. This thing, let's draw a correct free body diagram, and that will look like this. Block or this liquid column, downward force mg, normal reaction n. For every action you have an equal and opposite reaction. So this is the base of the beaker. On the beaker you get a downward normal reaction, something like this. Let's say this duster represents the liquid column. So if you place it on your hand, the hand is basically bottom of the beaker. जब ये इस तरह से रखा हुआ है, मैंने आपसे पूछा कि आपके हाथ ने इस डस्टर पर कितना फोर्स लगाया, n. इस डस्टर ने आपके हाथ पर कितना फोर्स लगाया, that is also n. Remember, it's not mg. It is what? n. So, what is pressure according to the definition we developed? If I say find out pressure on the liquid column right here, then it will be n divided by A. If the whole setup is at rest, if it is not at rest, then what will happen? We'll see that also. But right now, if the whole setup is at rest, then you know that this normal reaction is balancing what? Weight of the body. N is equal to mg. This therefore becomes mg divided by A. So what is pressure acting at the bottom of the liquid column? Mg upon A. At the same time, what is pressure acting at the beaker, base of the beaker? That is also what? Mg divided by A. for this particular setup, because N is what? Mg. Means, it means this. What is pressure at the base, at the bottom of the liquid column? Mg upon A. ये कहां से आया? मेरे हाथ ने liquid column को push किया. But in turn, this liquid column is also pushing my hand down. With what force? And they both are what? Same, because of action and reaction, and therefore same pressure is acting at the base of the beaker also. Now, we know that we can calculate mass in terms of volume. This liquid, its mass will be what? Volume multiplied by density. What is volume of this liquid column? If cross-sectional area is A and height is h, then volume is simply A multiplied by h into rho, that gives you mass. Pressure, therefore, is A h rho, this is mass, multiplied by g divided by A, or h rho g. So pressure is coming what? Cross-sectional area A multiplied by the height of the liquid column into G, provided beaker is at rest. Note down this much, and those of you who can answer the second part, draw a second figure. If this beaker is accelerated up with an acceleration of A, first everybody will note down this when beaker is at rest. In the second part, we have placed the beaker inside a lift, hint, lift, which is going up with an acceleration of A. Then at depth h, write down the pressure in the comment box. Note down this much. Good. So, in laws of motion, we have seen this thing that when you place an object inside a lift and lift goes up, then normal reaction is given by m times g plus a. Beaker is no longer at rest, is going up with an acceleration of a, and therefore m, normal reaction will be what? M times g plus a, which means it's not correct to remember p as mg upon a. It is better to remember p as n upon a, which in this case will be, let me do the changes in this part only, and you can write it in a separate note. Replace this G with G plus A, and your pressure therefore becomes H rho multiplied by G plus A. Many of you could answer this. Good thing. Write down P as H rho G plus A, and now the beaker is coming down. If the beaker is coming down, then you know that pressure will be what? G minus A, which gives us an interesting result type of thing. Let's see how many of you will answer this. If I hold a beaker, let's say this bottle, just filled with water, this height is H. Right now pressure at the bottom is H rho G. But if I drop it, it's in free fall. Then what will be pressure at the bottom of the bottle? Write down this in the comment box fast. If you drop this beaker, then what will be pressure at any point? In fact, what do you think is the correct answer? Good. If we drop this beaker, then it has a downward acceleration, and for downward acceleration, normal reaction will become what? G minus A. If this is G minus A, then your pressure is what? H rho G minus A. And when I say a freely falling bottle or a beaker, freely falling things means your A is also G, and therefore pressure will be what? 0. Note down this and write down the statement. In a freely falling beaker, pressure at every point, anywhere you go, everything is under free fall. Pressure at any point will be 0. Pressure at any point will be 0. Now, write down Pascal's law. What is Pascal's law? If you have a liquid or a fluid at rest, then Suppose you are at this depth, and let's say this depth is h. This much is h. Then pressure in all directions. If you go and measure pressure in any direction, then that pressure will be H rho G only. It will be same everywhere. Draw the figure, write down at rest, and then we'll write a statement, and then I will prove this thing also. Now let's see how we can prove that pressure is same everywhere. And what does it mean when I say pressure is same everywhere? This small place, let's draw this small place in the form of a triangular prism. And you're looking at the side view of the triangular prism. What is this triangular portion? It can be any shape. It doesn't have to be a triangular shape. It will be easier for us to understand, and therefore we are taking a triangular shape. You can take any type of shape and the law is valid. But let's start with this. So we have a triangular prism. Some force is coming from this side. Remember, on the entire surface, force is this. Force is acting everywhere, and I have shown it at this place only. Let's call it F1. It should be a normal reaction force. Force coming from this side is F2. Force coming from this side is F3. These are the forces coming on this prism element, and it's a very small element. It's a very, very small prism. If it is very, very small, then we can neglect its weight. What basically is happening? Look here. The beaker is filled with water, and we have taken a small prism. Not this large, very small. Just so that you can see it, we have drawn this much large. Now, all the liquid on top of it is going to push it this way. This force is F1. Similarly, some force is coming from this side. The force which is coming from this side, let's call it F2. Force coming from the bottom, it is F3, and mass of the whole element is mg, which is approximately 0 because it's a very small prism. When I say at a given height, at a given depth, then you are basically looking at a point. So the size of prism is just a point. Now, that's how forces are acting on the prism or any imaginary water volume. हमने क्या किया हुआ इस पूरे के पूरे लिक्विड के अंदर, मैंने आपसे बोला जस्ट इमेजिन प्रिज्म टाइप थिंग। आपको कोई प्रिज्म लाकर रखना नहीं है वहां पर, जो वाटर वॉल्यूम प्रेजेंट है उसी के अंदर हमने क्या इमेजिन कर लिया, दैट इमेजिन अ triangular prism like this. Forces coming from this side, this side, this side, they are represented by this, and we are interested, in what? Normal reaction forces. So all the forces are perpendicular. Pressure on this side, let's say this surface area is A1, similarly this surface area is A2, and the bottom surface area is A3. जो अपना triangular portion है, bottom area is what? A3, this side, perpendicular side, A2, and the hypotenuse is what? A1. It's not the length, it's the area. Something like this. If I say you're looking at this, you're looking at the side edge, but then the side edge has certain surface area. That surface area is what? A1. Now, what is pressure coming from this side? Pressure coming from this side will be P1, which is F1 divided by A1. Pressure on this face, P2, which is F2 divided by A2, and pressure on this side is P3, which is F3 divided by A3. Now Pascal, he says that all these pressures are same. How do we prove that? Simple, resolving a vector into its components, and we can prove this part. Note down this much and this, and then I will resolve the forces and complete this proof. Look here. Say this angle is theta. This side length is L1. Area is A1, and I'm talking about side length L1. This side length is L2, and this side length is L3. The force which you see in the figure, it has two components. One is this, and the other one is this. These are the two components shown in blue. If this angle is theta, then look here. This is theta. This is 90 minus theta, this much. This is 90 minus theta, then this is theta. If this is theta, then this angle is theta. Simple है. Theta, 90 minus theta, theta, theta. And therefore, this downward component is F1 cos theta, and the horizontal component is F1 sin theta. F1 cos, F1 sin. Which means in this figure, this whole thing, if you consider it just as a point, is almost a point, then the way forces are acting on it is this. A force is coming from this side, which is what? F2. A force is coming from this side, which is F1 sin theta. A force is coming from this side, which is F3, and the downward force is this component, which is F1 cos theta. Now, this whole liquid is at rest. If it is at rest, then you can simply balance all the forces. Horizontal ones, they will cancel out each other simply, and similarly the vertical ones will also cancel out each other, thus giving you what? Giving you this information that F2 is equal to F1 sin theta and F1 cos theta equals to F3. F1 cos theta is what? F3. Once you find relationship between F1 and F2 and F1 and F3, we can establish relationship between pressure P1, P2 and P3. किस तरह से देखना है यहाँ पर. अगर ये थीटा है ना, what is sin theta in this figure? What is sin theta? L2 divided by L1. What is cos theta? L3 divided by L1. L3 divided by L1 is giving you F1 into L3 divided by L1, which is equal to what? F3. Now, suppose this prism has a depth of x. Depth of x means this. The face which you are looking at, this side is what? L1. But the depth part, this, let's say is x. This is L, this is x. How much is the area? L into x. And that will be for all three. What is A1? L1 multiplied by x. What is A2? It will be this side L2 and the depth, which is x. And A3 will be L3 multiplied by x. If you have got A3 L3x, A2 L2x and A1 as L1x, then let's write down these things in P1, P2 and P3. What is P3? Keep looking. What is P3? F3 divided by A3. What is A3? L3 multiplied by x. L3 multiplied by x. Now, What is F3? What is F3 divided by L3? देखना, F3 divided by L3 is what? F1 upon L1. F1 upon L1. F1 upon L1. और साथ में क्या है अपने पास? X. But what is L1 into X? L1 into X. L1 into X is this area. And therefore, this is F1 divided by A1. But what is F1 upon A1? P1. We have proved that P1 is equal to what? P3. This pressure is same as this. We can again start with F2. We can again start with P2, and ultimately you will find that the same thing is coming P2 only. And that I leave as a homework. This much I have done for you. You can yourself prove that using same analysis technique that P1 is equal to what? P2. Put on this, and then I'll give you one line method of proving this Pascal law also. But by the way, if you understand everything so far, then write down yours in the comment box and note down each and every part. Now, in this part, I had to use L1, L2, L3, and then I need to draw a triangle like this. But if you are dealing with a prism, then all these faces have same depth of x. If they all have same depth of x, then we can do something like this. Look, like this. This is A1. This angle is theta. This area is A2. But I can say that this A2 is nothing but A1 cos theta. As if I am resolving area. Although area is not a vector, but I can still resolve it. Why? Because length as a displacement can be considered vector. So this length has this horizontal component multiplied by the depth, which is x, and x is same for all the three faces, and therefore I can say what resolving area, the way you resolve vector, is also valid in this figure. This is A2. Similarly, this A3 is A1 sine theta. So we have resolved what? Areas. A1, its horizontal component cos, vertical component sine, provided every face has same depth x. So once you resolve your areas this way, what is P1? F1 divided by A1. What is P2? F2 divided by A2. P2, do one thing, this was A3, make it A3 so that there is no confusion. This face was A3, make it A3, this was A2. Now, what is P2? F2 divided by A2. And what is A2? A2 is A1 sine theta. And what about F2? What about F2? F2 is already what? F1 sine theta, coming from this simple vectors at equilibrium. This small portion is at rest. At equilibrium, this force is equal to this. So F2 is what? F1 sine theta. F2 is what? F1 sine theta. Sine and sine cancelled. What is P2 coming? F1 upon A1. F1 upon A1. And therefore, they both are equal. Similarly, what is P3? P3 is F3 divided by A3. P3 is F3 divided by A3. What is F3? What is F3? F3 is what? F1 cos theta there. So this is F3, which is F1 cos theta divided by A3. And what is A3? A1 cos theta. A1 cos theta. Cos and cos cancelled. What is P3 coming? F1 upon A1. P1 is F1 upon A1, and therefore P1, P2, P3, they all are same. Which means in a liquid at any depth, if system is at rest, pressure coming from all the sides is what? Same. Note down this in just one line. Don't forget to draw this figure. Now let's try to visualize this whole thing. The concept of pressure being same everywhere. Let's understand it with the help of a rope. The feeling part. Look here. Suppose we have a tube, a cylindrical tube, base is closed, you fill it with some water. This is H. You know that pressure will be H rho G. But now, let's have the same tube but in this form, this side closed. थोड़ा सा मोड़ दिया हमने ट्यूब को. Fill the whole thing with a liquid. But liquids are what? Fluids, and therefore they can easily change their shape. Once you change the shape, if this height is h, and people ask you what is pressure over here, Pascal's law, it tells us that pressure at this place is also what? H rho g. At this place, what is pressure? H rho g. This height is h. If you make a bend in the pipe at the bottom, liquid is going to reshape itself and then it is going to push using same force, therefore producing same pressure as H rho g. लेकिन मैंने आपसे क्या बोला, इस चीज को अगर आप एक रोप से विजुलाइज करोगे तो और भी आसान हो जाएगा. किस तरह से होगा देखना है यहां पर. Although this setup is also sufficient if you want to understand the Pascal's law, it gives you the feeling that liquids can flow. Now look here. मैंने आपसे बोला कि भाई एक rope है अपने पास and there is a mass M hanging over here. What will be tension force in the rope? T will be what? mg. Now, if I ask you that the setup is something like this. Rope, there is a pulley, frictionless. What is tension in this rope? कुछ भी हो जाए. Downward force कितना है अपना? mg. यहाँ भी tension क्या होगा? T. यहाँ भी tension क्या होगा? T. The rope is just like a fluid. It can reshape itself. So whether you hold this mass vertically, straight, or with the rope, with the help of a pulley, in this arrangement, force remains what? Same. T is balancing what? mg. Everywhere T is coming, mg only. If you take a pulley like this is M, and if I ask you to hold this rope from this point, then what is the force which you are going to apply? That force will again be what? mg. जैसे rope किसी भी force को direction change करने में help करती है without changing its magnitude, mg, provided things are at rest. Otherwise, T will change. mg. Everywhere tension is what? mg. Everywhere tension is what? mg. In the same way, this fluid, by giving it this type of shape, produces pressure everywhere same. अगर ये चीज इस तरह से वर्टिकल शेप की जगह आपने ट्यूब को इस तरह का एक बैंड दिया, fill the tube up to height h. If they ask you what is pressure at this place, आंसर इज H rho G. जो अपना लिक्विड है, being a fluid, it can transfer same pressure in all the directions. That's what is your Pascal's law in this mathematical form. If you wish, you can note down this much information as a side note. This is just for your visualization. Just once again, what do I say that being a fluid, it is giving us an advantage. It should be mentioned always that the thing which we are dealing with is a fluid, something which can flow, something which can change its volume, its shape. In the same setup, suppose somebody gives you an iron rod, you have a pipe, and in this pipe, which is closed at the bottom, if I ask you to place a rod, an iron rod of length h, then what will be pressure over here? Pressure will be H rho G only, where rho is density of this rod. Now it's an iron rod or anything which is rigid. Now if I ask you to create a bend, close this side and place this rod again inside. If you place the rod, it will remain like this. ये अपनी shape change नहीं करेगी. अगर shape change नहीं करेगी, then what is pressure over here? Zero. Because this rod, this iron rod, cannot flow. It's not a fluid. It's a solid thing. It's a rigid thing, and therefore, in this case, this argument does not work. Anything which can flow will always give you Pascal's law, provided system is at rest. If you understand this visualization, then write down yes in the comment box. Good. We can develop a good question with the help of this Pascal's law, and the question is good. Result is useful for everyone. Try to understand the process, working method. The thing is, we have a beaker. Let's say an empty cube. It's a cube. For simplicity, take a cube of side length L. Beaker in the form of a hollow cube. And this cube, we have filled a liquid. And mass of the liquid is what? M. Density, rho, things like that. But mass of the liquid is what? M. What is force acting at the bottom? This bottom base of the beaker, what is the force acting on this due to this liquid? बहुत easy है और आपने को बताया कि ये क्या होगा mg. Nothing special about it. पूरा का पूरा liquid mg इस फेस पर. Now, what is the force on this face? F dash. This side face is also experiencing some force. Why? Because all the liquid which you see is creating a pressure in this form. देखना, जितना भी लिक्विड है ये इधर भी प्रेशर देगा, इधर भी देगा, इधर भी देगा, इधर भी देगा, इस तरफ भी देगा. And all the liquid was pushing the beaker, the base of beaker downwards. At the same time, using the concept of fluids, ये जितनी भी tubes दिख रही हैं, artificial tubes, imaginary tubes, all these tubes, you can see that they are pushing the side face this way. So all this force, we have called it what? F dash. And the aim is to find this F dash. समझना किस तरह से F dash कैलकुलेट कर रहे हैं, समझ में आ जाए बहुत अच्छी बात, नहीं आएगा, remember the result. Now, first tell me this, can I say that F dash is pressure multiplied by area? And when I say area, it is simply what? L square, because it's a cubical thing. This is a cube, this is L, depth is also L this way, and therefore pressure into L square. I need to find what? P. The point is, can I use P into A or simply P into L square, force as pressure into area? Can I do that? The answer is no. Why not? Look at these depths. They are different. So pressure over here will be H1 rho g. For some other depth, it will be H2 rho g. For some other depth, it will be H3 rho g. So at different heights or depths, pressure is different. Whereas in this case, at every place, pressure is same. And is what? H rho g. H is what? L rho g. So if somebody wants to use F as P into area, it will simply work. Why? Because everywhere pressure is same. L rho g multiplied by area. What is the area of a base? It's a cube. That is again what? L square. What is this? L. What is this? L square. Together, L cube. What is that? Volume. Volume into density, mass. This becomes what? mg. But for the side face, I cannot use P into area because P for the entire cross section is not same. And if things are not same, we use what? Integration. So we cannot find pressure in this form or force in this form. Instead, we need to use this. dF. Again, I'll be spending 5-10 minutes on teaching you integration, because in 12th and after 12th in competitive examination and all, you have to have knowledge of integration, otherwise it will be tough for you to clear these competitive examinations, and integration is very easy. And as I told you, if you find it difficult, just remember the result. I cannot use F dash, instead I will be using dF dash P into dA. थोड़ा सा टाइम इस चीज को समझने में. But before that, note down this much, and then I will teach you what does it mean Why do we write this? And then how do we integrate this? Mention everything, write down everything. देखना और समझने की कोशिश करना, अच्छा लगेगा देखना. This is the side face. This side. From the top, at depth x, take a very small strip. If I say it's a small strip, then this much is dx. And you know what is the length of this thing? L. ये जो साइड फेस था उसकी पूरी लेंथ कितनी है? L. I hope you can visualize this thing. This is the box. Imagine a cube. This is the side face. This side is what? L. From the top, at a depth of x, we have taken a very small element dx. क्यों लिया हमने? अगर ये dx है बहुत थिन, तो फिर हर जगह पर आप कहीं चले जाओ, प्रेशर क्या होगा? H rho g. What is H? X rho g. अगर मैं यहां कहीं आऊंगा तो x चेंज हो जाएगा. इस पूरी स्ट्रिप पर x क्या है? सेम. ये मत सोचना कि सर ऊपर से नीचे तक स्ट्रिप में प्रेशर चेंज हो जाएगा. होगा, लेकिन कितना? ऑलमोस्ट नेग्लिजिबल, क्योंकि स्ट्रिप की विड्थ कितनी है? dx, which is almost 0. But now, since I have the strip, I can easily find its area now. What is the area of the strip? L multiplied by dx. This is L. The strip is a rectangle. L dx. So how much force is acting on the strip? df dash. What is pressure? What is force? Pressure. How much? X rho g into area. L dx. I can write df as p dA, but I cannot write f as p into a. इस पूरे एरिया पर प्रेशर सेम नहीं है. यहां कुछ और है, यहां पर कुछ और है, लेकिन इस स्ट्रिप पर हर जगह प्रेशर क्या है? सेम. एंड देयरफॉर आई कैन राइट प्रेशर इनटू ए. खत्म. फाइंड क्या करना है अपने को? एफ. डीएफ को एफ में कन्वर्ट करने का तरीका क्या है? इंटीग्रेट. बच्चा इस तरह का इंटीग्रेशन कर सकता है. क्या लिखा हुआ है? ये x और ये क्या है? dx. व्हाट इज द इंटीग्रेशन? x स्क्वायर बाय 2 rho gl out x dx. its integration is what? x square by 2. लेकिन आपको अब इंटीग्रेशन को बताना पड़ेगा. कहां से कहां तक? हमने बोला यहां से. व्हाट इज दिस प्लेस? x equals to 0. यहां तक. व्हाट इज दिस प्लेस? x equals to L. यहां से यहां तक जितने फोर्स लग रहे थे उन सबको ऐड कर दो. दैट्स इंटीग्रेशन. सो द लोअर लिमिट इज व्हाट? 0. अपर लिमिट इज व्हाट? L. किसकी लिमिट्स यूज होंगी? x की. 0 to L. लोअर ये नहीं है, हमने x कहां से लिया है? यहां से. तो लोअर मींस इनिशियल, फाइनल. इजी काम है लिमिट पुट करना, पास कर दे रहे हैं भाई. रो जी एल, एक्स को अपर लिमिट दोगे तो क्या बनेगा? एल स्क्वायर. 0 खत्म. व्हाट इज दिस? एल स्क्वायर बाय 2. लुक एट द इंटरेस्टिंग थिंग. एल एल क्यूब, वॉल्यूम into density, mass. What is the final result? mg divided by 2. तो अगर आपके पास एक क्यूब है, उसमें आपने एक लिक्विड फिल किया, तो बॉटम पर कितना फोर्स लग रहा होगा? कंप्लीट वेट ऑफ द लिक्विड विच इज mg, और साइड फेस पर mg by 2. An important result for competitive examinations. How many of you understand this integration and all? गुड, बहुत सही. जितने लोगों को आया, जिनको नहीं आया कोई इश्यू नहीं, याद रखना mg by 2. जितने लोगों को आ गया है उनकी लाइफ थोड़ी सी और डिफिकल्ट बनाते हैं. आई एम गिविंग यू द होमवर्क. जो लोग अभी डिफिकल्टी फील कर रहे हो, जस्ट को एक बार और देखना, समझ में आएगा. जिनको आ गया है, एटलीस्ट दे आर क्लेमिंग दैट दे अंडरस्टैंड दिस. Instead of a cube, take a cuboid. And this cuboid has what? Side lengths like this, A, B, and the third one is what? C. Just like this. So instead of a cube, you have a cuboid filled with water. Height is B. This side is A, and this is C. So when you fill a liquid inside, what is force at the bottom? mg. उसमें कोई इशू ही नहीं है. इस बॉटम को क्या संभालना है? पूरे के पूरे लिक्विड को. What is force on this side? ये अलग साइड है. What is force on this side? The homework is find out force on this and find out force on this. How you can verify your answer is correct or not? If you say that all sides are same, L, 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 your answer should come what? mg by 2. But हमारे क्यूब की डायमेंशंस क्या क्या है? फिर से विजुलाइज कर लो. This is A, this is C, and the height is what? B. Note down this, and then you can leave. Thank you very much.